Okay, so we're going to be looking at quadrilaterals in GeoGebra. So first we have a base quadrilateral A, B, C, D with the side lengths, and we're going to construct the midpoints of each of these segments and make another quadrilateral based off their midpoints. So for the I have the constructions over here, just hide so they're not in the way. And then we're going to go ahead and show the midpoints. So we got E, F, G, and H. And then we have our quadrilateral E, F, G, H, just by connecting our segments, and we have the side lengths of those. So we're going to look at this and make different conjectures based upon E, F, G, H, and A, B, C, D. So if we look at E, F, G, H, we can automatically see that opposite side lengths of this quadrilateral are equal. So we can prove this by removing lengths of A, B, C, and D. So if we do, you can see that EH and FG still stay the same no matter where you move this quadrilateral, or where you move this point B. So to look at EF and HG, we'll move around C. And if we still look, our side lengths are still the same. EF and HG remain the same no matter where we put C, and same with D and A. All of our lengths stay the same. So we can show that that conjecture is proven true. So another conjecture we can make, besides looking at side lengths, we should be looking at lengths of measurement, but let's look at angle lengths. So we have angle of E, F, G, and H. So let's see if we can find. There we go. So we can see all of our measurements. So if we look here as well, we can see that opposite angles are the same. So we got angle E is the same as angle G. Then we got angle H is equal to angle F. So once again, we'll prove this by changing measurements or moving segments. So we can move one and it changes all, but if we still notice, no matter where we move it, each of these measurements are still saying the same, opposite from each other. So we got angle E and G are still the same no matter where we move it. And then we also got F and H are still remaining the same. So we'll move all 4 points just to be sure that we're true. And we move C, and we are still proven true. We'll move D, and our conjecture is still true. And we'll move A. If we look, our conjecture is still true. So one more conjecture we can make is looking at, let's take out the angle lengths, and we can look at the area of these two quadrilaterals. So let's throw in the area of ABCD, which is 37.6, and we'll move it let's move it up here. We'll just have it right here under the E. And then we'll show EFGH. We'll put it kind of in the middle. So if we look, as of right now, just by looking, it looks like we make a conjecture that the area of ABCD is double the area of EFGH. We just have the notation different. So HEFG or EFGH, either one work. But it looks like this is the midpoint quadrilateral. EFGH is half the area of ABCD. So to prove that, let's just move around some points. So if we move up B, it looks still the same. See if we can get it spot on. There we go. We got 21 and 42. 21 times 2 is 42, and the half of 42 is 21. So right now our conjecture is still true. See, here we have 42.7 and 21.3, which is not exactly, but if we carried out more digits, it would show that it's probably 21.35. We just have our decimal place just going at 1. So this is more than likely 21.35, and this is 42.70. So which is still proves that our conjecture is true. So we move this down. We'll try to get it right on. There we go, 21 and 42. We'll just move, let's see, we'll go down some. Let's get that on 20 and 40. So it's true. So we'll move this last point. Let's get it right on. Then we got 23 and 46. So we can prove that this conjecture is also true.